People sometimes ask me how I learned to think the way I do. They assume there must be some secret behind it. Some trick I picked up along the way, some technique I stumbled onto. But the truth is, I don't think of myself as particularly smart. What I did figure out, and it took me years, is something that sounds almost too simple to be worth saying. Most people don't actually think. They accept. Let me explain what I mean. When I was about 10 or 11 years old, my father used to take me walking in the Catskill Mountains. We'd move through the woods together, and he'd point at different birds along the path. One day he pointed at one and started listing its names. In Italian, it's called this. In Portuguese, something different. In Chinese, something else entirely. Then he paused and said, "Now you know what people in 3 countries call that bird. But you still don't know a single thing about it." He pointed out that the bird was constantly pecking at its own feathers. And he explained why: tiny lice eating the protein, the bird spending half its waking life just trying to stay clean. That distinction, between knowing a name and knowing a thing, stuck with me for the rest of my life. Most of what we call education is really just the accumulation of labels. You learn to say the right words in the right order. You learn to recognize the correct terminology. And the whole system rewards you for doing this, which means most people never notice that they've confused labeling something with understanding it. Real thinking means asking what is actually happening. I noticed this pattern later, sitting in advanced physics lectures at MIT and Princeton alongside some of the sharpest students in the country. The professor would fill the board with equations, genuinely beautiful equations, and everyone would copy them carefully into their notebook. Then at the end of class, someone would raise their hand and ask what the equation meant. The professor would re-explain it using different symbols, different mathematical language. The student would nod, satisfied. And I'd sit there thinking, but what does it mean? Not what does the equation say on paper. What is actually happening in the physical world that this equation is trying to describe? There is a real and important difference between those two questions, and most educated people, even very educated people, never notice they're conflating them. They can repeat what they've been told. They can pass the exam. They know the vocabulary, and they mistake all of that for understanding. It isn't. After the war, I went to Brazil to teach physics at the university in Rio. Beautiful students, genuinely serious about their education. But something was immediately wrong. These students could recite entire textbooks from memory. Ask them to reproduce a derivation, perfect. Ask them to define a term, precise. Ask them about position and momentum and Planck's constant, flawless. Then I asked them something simple. What happens when you shine polarized light through a filter at a certain angle? They couldn't answer. None of them. They knew what the textbook said the answer was. They'd never thought about why it was true, what was physically occurring, what it would actually look like if you watched it happen. So I started asking differently. I'd say, forget the textbook for a moment. You're standing on a beach, and sunlight is reflecting off the water. Why is that reflection brighter from some angles than others? Same blank faces. They had developed the habit of memorizing what they were told. They had never developed the habit of thinking about the world directly in front of them. That's when I understood something important. Thinking isn't a talent. It's a practice. It's a habit you build deliberately. And most people never build it because no one ever showed them how. So how do you actually build it? The first thing I learned, and I did this naturally as a child without realizing it was unusual, was to always translate whatever I was learning into something I could see, touch, or vividly imagine. When someone explained atoms to me, I didn't just memorize the definition. I tried to picture them, bouncing around, colliding, moving. I'd ask myself, if I had tiny enough eyes to actually watch individual atoms, what would I see? Later, studying at MIT, I did the same thing with equations. People thought I was slow because while they raced through problem sets, I'd sit for an hour staring at a single equation. But I wasn't being slow. I was translating. I was asking, what is this equation actually describing? If I could watch this process unfold in real life, what would it look like? Sometimes I'd invent odd little thought experiments. When I was trying to understand electromagnetic fields, I'd imagine I had shrunk to the size of a single electron, floating in empty space. What would I feel? If another charged particle drifted near me, how would I sense it? What would push me or pull me? This probably sounds childish, but it worked. Because once you can see something clearly in your mind, you actually understand it. And once you genuinely understand it, you never forget it. Here's what nobody tells you. You cannot think clearly about something you cannot visualize. Most people skip this step entirely. They learn the abstraction first. The formula, the technical term, the theory, and never connect it to anything concrete. So it floats in their head, disconnected and ultimately meaningless. Then they wonder why they've forgotten everything a week after the exam. The second thing I learned, and this took longer, was to keep asking why. Not just once. Over and over, the way children do. Children are remarkable at this. Ask a child why the sky is blue, and they'll follow your answer all the way down until you finally have to admit you don't actually know. We lose that somewhere. We get embarrassed to ask basic questions. We don't want to look foolish. So we nod along and pretend. But that's a disaster. If you don't understand the foundation, everything built on top of it is unstable. I remember a student at Caltech who came to me confused about the uncertainty principle. I asked him to explain what he thought it meant. He immediately began reciting the textbook definition: position, momentum, Planck's constant. I stopped him. Don't tell me what the book says. Tell me what you think is actually happening. He couldn't. He'd memorized the words without ever thinking about the underlying reality they were pointing to. So we started from scratch. I asked him, if you wanted to measure where a ball is, what would you actually have to do? Look at it. And how does looking at something work? We worked through it together. Light bouncing off the ball, entering the eye, that's how you see its position. Then I said, now imagine the ball is so incredibly small that the light you use to look at it actually moves it when it bounces off. What happens then? I watched his face change. He got it. Not because I gave him a better definition. Because he finally thought about what was physically happening. That's the whole method, really. Don't accept anything until you can explain it to yourself in your own words, using your own mental images, your own comparisons. If you can't do that, you haven't understood it yet. And that's completely fine. Just don't pretend you have. The third thing, and maybe the most important, is that I learned not to be afraid of not knowing. This sounds obvious. It isn't. Most people are genuinely frightened of admitting they don't understand something. They're afraid it will make them look unintelligent. So they fake it. They nod. They use the correct vocabulary without knowing what the words actually mean. But here's what I came to understand. The most intelligent thing you can do is openly admit when you don't know something. Because the moment you admit it, you can begin actually learning it. But if you pretend you already understand, you stop asking questions. You stop thinking. You stay exactly where you are. I used to sit in seminars at Princeton and Caltech where some eminent physicist would give a highly technical talk. Everyone in the room would sit nodding as though they understood every word. Maybe some of them did, but I often didn't. So I'd raise my hand and ask a basic question. People would sometimes look at me like I'd said something embarrassing. But afterward, inevitably, 2 or 3 people would come up and say, "Thank God you asked that." I had no idea either. Much of what passes for expertise is really just people who have learned the language of a field without understanding its substance. You can tell, if you pay attention, because when you ask them to explain something simply, they can't. They retreat into jargon. They make things sound complicated because they themselves are confused. So I made a rule. If I cannot explain something to a first-year student, or to a child, or to someone with no background in the subject, then I don't actually understand it myself. And that's fine. It just means I need to think about it more. There's one more thing, and it might sound strange. I learned to genuinely enjoy not knowing. To find it exciting when I encounter something I don't understand, because that means there's something new to figure out, something new to play with. When I came back from Los Alamos after the war, I was burned out. Physics had become heavy and serious, all equations and pressure and urgency. So I made a decision. I was going to stop worrying about important work and just play. Follow whatever seemed interesting, without any goal beyond the interest itself. One afternoon I was in the cafeteria and someone tossed a plate into the air. As it spun, I noticed the blue Cornell medallion on the rim was rotating at a different rate than the plate was wobbling. I thought, that's strange. I wonder why. So I went back to my office and worked out the equations. Not because anyone asked me to. Not because it seemed important. Just because it was interesting. That little problem, that genuinely trivial thing I did for pure amusement, eventually connected to principles of rotation and angular momentum that contributed to work I did years later. Work that, as it turned out, was part of what led to the Nobel Prize. But I didn't know that at the time. I wasn't trying to do important work. I was playing. I was curious. And I think that might be the real secret, if there is one. You don't force your brain to think differently. You let yourself be curious, the way children are curious before we teach them to be embarrassed about not knowing. You ask questions. You try to see what's actually happening rather than just accepting the label. You admit when you don't understand something, and you keep turning it over until you do. I've spent my whole life around people who are considered genuinely brilliant, Nobel laureates, extraordinary mathematicians, physicists of real depth. And what I noticed is this: some of them were unusually talented. But most of them were simply people who never stopped asking questions, who never accepted something just because everyone else did, who kept thinking about a problem long after everyone else had moved on. Anyone can do that. It doesn't require special ability. It requires persistence. It requires caring enough to actually think something through rather than just absorbing it. So the next time someone tells you something, anything at all, don't just take it in and file it away. Ask yourself, what does this actually mean? Can I picture it? Can I explain it to someone else in my own words? If the answer is no, you don't really understand it yet. And that's not a problem. That's exactly where the thinking begins.